Okay, Biswas, welcome to YourPedia. Let's start your full mock for IIT Madras for robotics and power
Power
system engineering. So, start with your introduction.
Sir, my name is Moina Vishya. Sir, I am from West Bengal. I did my secondary and high secondary from Krishnagar AV High School. After that, I did my B.Tech in electrical engineering from Academy of Technology, West Bengal with 9.45 CGPA. And my B.Tech project is a remote control single phase PWM inverter.
Single phase
Uh, Single
PW
phase
inverter.
remote control PWM inverter.
PW inverter.
Yes, sir.
What do you mean by remote control?
Sir, by using some microcontroller based control, we are going to change the output voltage of inverter by PWM technique.
Okay, so using remote control. So, what is the main difference between that uh, inverter, online inverter, which you have heard in the have been heard in the solar system, and offline inverter.
Sir, in online inverters, generally we are going to control by IoT based control, and we are going to use the remote control. But offline inverter, there is a fixed output voltage. By changing the load set, the output voltage of that inverter can be changed. In offline mode inverter, we do not cannot control the output voltage. But sir, in case of online inverter, we can change the sinusoidal pulse signal, or by varying the PWM technique, we sir generally can control the output voltage of the inverter. That is our online inverter.
Hmm. Okay, you have applied for the two branches,
Yes,
robotics
sir.
and power electronic power system engineering.
Yes, sir.
So, which one will you prefer?
Sir, I prefer myself power system engineering.
Power system. अच्छा, power system में which mathematics generally used in
Sir,
power?
sir, in case of sir,
मैथमेटिक्स का कौन
okay, sir. Sir, in case of sir load flow analysis, we generally use sir matrix theories, and in sir load flow solution or power flow solution, we generally use a numerical methods techniques. And so numerical methods techniques and like Newton Raphson and Gauss iterative, these iterative methods are also used in sir stability analysis, power system stability analysis. In case of the swing equation, equilibrium criteria purposes also.
अच्छा यूनिट मैट्रिक्स क्या होता है व्हाट इज यूनिट मैट्रिक्स
Unit matrix are only sir diagonal principal diagonal elements are one and other all elements will be zero. That is unit matrix.
so which are your favorite subjects
Sir, power system, electrical machine, power electronics, and network theory. Sir.
अच्छा we analyze the transmission line with two port network
Sir, in case of transmission line representation, we generally use sir ABCD parameters in two-port network.
ABCD parameter okay अच्छा AD माइनस BC इक्वल्स टू 1 होता है तो ये किस कंडीशन को सेटिस्फाई करता है
ये सर reciprocity condition को satisfy कर रहा है sir.
व्हाट डू यू मीन बाय रेसिप्रोसिटी
Reciprocity means sir, uh, sir, reciprocity. Sir, from both the ends, the network will be identical like that.
अच्छा, ये सभी केस के लिए वैलिड होगा ट्रांसमिशन लाइन के लिए, whether it is long transmission line, short transmission line, or small
Sir,
transmission line.
sir, please can you repeat once, sir? I cannot.
That condition will be valid for all the transmission line, long, short, and medium.
Yes, 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 sir. Yes, sir. It is definitely valid for all three.
Okay. Can we convert the medium transmission line into the long transmission line?
Sir, generally cannot convert sir medium transmission line into long, but by doing some approximations and like cos hyperbolic and sin hyperbolic functions, by doing some approximations, we generally convert sir long transmission line into medium transmission line for our easier calculation purpose.
अच्छा, जीरो स्विचिंग होता है, एक जीरो स्विचिंग, वो क्या होता है?
सर जीरो स्विचिंग मतलब सर जनरली सर जो हमारा सर वोल्टेज होता है और करंट वेवफॉर्म होता है ना, वो सर साइनोसॉइडली वेरी करता है। इन केस ऑफ फॉल्ट इफ वी वांट टू ट्रिप द सर्किट ब्रेकर और रिले, जनरली हम सर जीरो टाइम इंस्टेंट पे जब करंट का वैल्यू जीरो हो उस इंस्टेंट पे स्विचिंग करने की कोशिश करते हैं, जाते क्योंकि सर कोई फ्लैश जनरेट ना हो और कोई शॉर्ट सर्किट जनरेट ना हो। दैट केस इज कॉल्ड एज सर स्विचिंग और जीरो स्विचिंग। Sir, this is related to current chopping phenomena.
ओके, किस ईयर में आपने कंप्लीट किया अपना बीटेक?
सर 2022 में सर।
2022 अभी कुछ कर रहे हैं आप?
नहीं सर, इस साल सर एडमिशन लेना है सर एमटेक का।
एमटेक में तो you want to go in the research or US for the sake of the ये एडमिशन लेना है?
Sorry sir, I cannot.
What is your aim of getting admission in MTech?
Sir, my aim is sir generally getting into sir good IIT in my core departments. Otherwise, sir, NITs in my core department.
Okay. चलिए, मैं इलेक्ट्रिकल मशीन से आई विल आस्क यू वन क्वेश्चन फ्रॉम द इलेक्ट्रिकल मशीन, ठीक है?
Okay, okay sir.
In the transmission line, ठीक है ना, during
Yes
the
sir.
transient condition we have that subtransient, transient and steady state reactance of the synchronous machine.
Yes sir.
What is the relation between them, and from where these parameter came arrive? कहाँ से
Okay
आते
sir.
हैं?
Okay, okay. Sir, in case of let us consider sir one synchronous machine or alternator is operating in steady state condition. Suddenly fault occurs. Then there will be the relative motion between uh, between the rotating magnetic field created by rotor and the uh, electric field produced by the three-phase winding in case of stator. Due to that relative motion of the magnetic fields, there will be some generation of some induced flux in damper winding and field winding of the rotor. Due to that, the effective reactance is got reduces and they are coming into parallel. That's why this is called the subtangent reactance, and the value of this reactance is smallest. Due to the in here the value of the fault current is the highest. After some time, the X by R ratio, inductance by resistance ratio of the field winding is higher than the damper winding, due to which this field winding is due to which the damper winding flux gets reduced, and this is not participate in the transient region. That's why the transient reactance is much higher than subtangent reactance. In case of steady
Okay.
state only,
Okay, man, good. Now, sir will take for the further technical. ठीक है, I will give you feedback.
okay.
Okay, Minal.
Yes, sir.
Okay. What is load flow?
What is load flow? Sir, we are generally, sir, in load flow analysis, we are doing, sir, power flow, active power flow and reactive power flow from generation station to the load end, sir, from one bus to another bus.
Hmm. What actually load flow is?
Load flow is the, sir, flow of active power and reactive power from source ends to the load end.
Okay. What is meant to be as a buses?
Bus generally, sir, in case of power system, bus is simply a node. There are different type of buses like PV buses, lag buses, PQ buses, and voltage control buses, etc.
Hmm. So bus is
In
yes. So bus is simply a load.
yes, sir, where we can control, sir, different parameters, sir, like voltage, power angle, active power, reactive power.
Okay. So can you write down the load flow equation?
For what, sir?
The Gauss-Seidel method.
Sorry, sir.
For Gauss-Seidel method.
No, sir, I don't remember that one.
Okay. When we talk about the fault, the two
Yes.
type of fault comes in the picture: symmetrical and unsymmetrical.
So generally, asymmetrical faults are occur line to ground faults.
Hmm. What is
The,
symmetrical fault?
sir, this is very rare in symmetrical faults. They are very rare to chance to occur. Symmetrical faults.
What are the type of symmetrical fault?
There are two type of, sir, triple line to fault and triple line to ground fault.
Okay, tell me one thing. When we are very much conscious about the type of the matrix,
Yes, sir.
right?
Yes.
Which form of matrix is formulated in the case of Newton-Raphson method?
Which so there is square matrix, sir, Jacobian matrix.
Jacobian matrix. What is Jacobian matrix?
Uh, so the Jacobian matrix, sir, this is used to, sir, to solve the Newton-Raphson iterative method, sir. The order is, sir, 2pq plus pv cross 2pq plus pv. This is the order of that matrix.
Okay. So in the load flow, we are using admittance matrix, while in the fault we are using impedance matrix.
Yes, sir.
Why?
Sir, in case of fault, sir, we generally see the driving point impedance. So uh, at, sir, driving point impedance and driving point voltage, or we generally use, sir, open circuit, because, sir, in case of fault we are assume the worst case situation. That's why we are generally consider the highest voltage at that bus. So there we are using, sir, Z bus matrix. That's why uh, vi by ii at that fault condition. So that's why we are using, sir, Z bus in case of fault. But, sir, in case of load flow, we generally use Y bus matrix, because here we need to just flow the power.
Okay. When we are uh, when we are in the step for power factor compensation or reactive power compensation or the voltage compensation,
Yes,
right? There are two type of method: receiving end method and sending end method.
yes, sir.
Okay. Can you differentiate it? That what are the type of sending receiving end method? And what are the type of sending end method?
Okay, okay, sir. I got. Sir, in case of sentiment, we are generally use, sir, SVR and AVR, sir. Sorry, AVR, automatic voltage regulator. This is the closed loop
Uh,
system. This is generally fixed with the generator, where it says if the terminal voltage of alternator is higher than generated EMF or not, and by seeing that, it will control the field current of the alternator alternative rotor. But in case of sir receiving end, there are two types. We are used generally sir synchronous condenser, that is sir overexcited synchronous motor for voltage compensation. Otherwise we can use sir SVC, static voltage controller, just like sir capacitor banks also.
Okay. So while using the shunt capacitor,
Yes, sir.
how this shunt compensation is fruitful?
Sir, shunt compensation is generally for sir capacitor. We get the sir abrupt change in sir power factor. That is that can be used for sir for limited type of loads. But in case of huge load or industrial load, we generally use sir synchronous condenser. There we can get sir very good and smooth power factor compensation.
Okay. If suppose if a transmission line
Yes, sir.
has a ABCD parameter, right?
Yes, yes, sir.
If the value of the A and D it is 0.85 at an
8.85.
angle 5,
Yes, sir.
okay, and the value of the B it is
Yes, sir.
200 at an angle of 75.
Okay, sir.
Okay.
Yes, sir.
Suppose the load is connected and receiving inside at unity power factor.
Okay.
Can you find out the active power?
Um,
Suppose VR and BS it is 275 kilovolt.
275 kV. Yes, sir. We can. We can. Um, returns.
Mm.
Sir, what is the value of delta, sir?
You have to find out no delta.
Yes, sir. Yes.
When VR is equal to BS,
Yes, sir.
what is the value of reactive power?
Hmm. Sir, we need to.
It is zero, no?
Yes, sir. Exactly, sir. There is no. Sir, what is the load, sir? Unity power factor, but the sir load in kilowatt or something you do not tell that.
It is what?
Sir, how much kilowatt, sir? Load?
You have to find out, no? How much kilowatt it is. Okay.
Sorry.
Last question. When I say the panther, zebra, moose, okay, what are these terms in the power system represent?
So panther, zebra,
Moose.
I did not have heard about that, sir.
Okay, one more question. What are the effect that what are the benefit that we are getting while using the transposition?
Sir, in case of transposition, we are generally getting the same inductance in each phases. That's why if we send the balance voltage from the sending end by doing the transposition, we generally get the balanced voltage in the receiving end. And also, sir, in case by using transposition, there is no interference of communication line which is running parallel with the power line.
Okay. Okay, done from my side. Something that you have to go through. Please go through the load flow.
Okay, sir.
Okay.
हाँ,
Effect of Earth on the capacitance between the conductors. This question they are asking.
effect of Earth in capacitance.
On the capacitance between the
Yes,
two conductor,
yes, sir.
and type of ACSR conductor that have used Panther Moose.
Type of conductors data.
Hmm, type of ACSR conductor,
Okay, sir.
right?
Yes, sir.
Okay, other part is fine.
Okay.
See, these type questions we ask when you go to the power system interview, the mostly question that is asked from the it is load flow.
Okay, sir.
They will simply give you the pen and the paper and or the black and board and set to write on the load flow equation.
Okay, sir.
Please read the load flow equation very much carefully.
Okay, okay, sir. I will done this today.
Okay.
Yes, sir. Very nice, sir.
Okay. Okay, done from my side. Okay, sir.
Menak,
हाँ, sir.
I think you have the good basic knowledge of power system as well as electrical machine. The question I asked you what that subtransient, transient, and so the same
Yes, sir.
question has been asked me my in IIT Kanpur.
हाँ सर, मुझे आईआईटी कानपुर से मिला है सर, पावर इंजीनियरिंग का सर। 6 तारीख को मैं जा रहा हूँ आप इंटरव्यू देने।
ठीक है. The same question was asked to me when I went there for a program.
ओके सर.
It is around 20 years ago. ठीक है ना? But
हाँ, हाँ.
the question is generally it is important question and you have the good knowledge of the power system. The one thing I ask you the I want to highlight you see that mm, how we can convert the medium transmission line into long transmission line
हाँ सर.
by
सर वो
increasing the
सर.
frequency of by increasing the frequency of the system.
ओके सर. यस, यस, यस. आई.
Increase the frequency of the system, then
यस, 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 यस.
all the parameters related to the medium transmission line will correlate automatically with the long transmission. ठीक है?
हाँ सर. और सर
Otherwise you are
बता.
good. ठीक है ना? We जो सर ने advise किया whatever he advised you regarding that load flow analysis and so उसको
हाँ, हाँ सर.
एक बार देख लेना. Otherwise
हाँ.
it is good. ठीक है ना? They will
हाँ, हाँ सर.
ask the basic questions. ठीक है?
ठीक
Good
है,
luck.
ठीक है.
All the best.
थैंक यू सर.